And today we're going to be talking about a bunch of different news items, and we're going to first be looking a little bit into Collins Aerospace. So what we're seeing right now is that Collins Aerospace has invested 14 million in a new production site. So Collins is a subsidiary of Raytheon. It does a lot of stuff in additive manufacturing. Raytheon generally, and Collins in specific. And the investment is going to take place in a site in West Des Moines in Iowa. It's a 9,000 square feet facility, and it's going to be doing engine components. And that's probably military, some defense, some non-defense, probably some space. But one of the interesting things I mentioned here is also land-based turbine components. So turbines we often really associate with the things that go very fast, but turbines are in a lot of things. There's thousands and thousands of turbines in tanks or in lots and lots of other kind of like vehicles as well. So that's a kind of interesting thing they would mention, a land-based turbine components as being an application for this as well. They also mention a system that has like 8 times the build volume of their existing systems. That's also going to be at the site. So we're unsure at this point whether that's like a large SLM system, AMCM, something like that, large Velo system. But that also means they have one of these large scale printers there as well. Now, turbine repair using DED is already one of the biggest applications for 3D printing in the defense world, and it's already happening in a really highly automated way. So you've got a production cell that adds material, then another a machine comes on, the machines the material away, and then you've got a new repaired turbine, good as new repaired turbine blisk. And this is already kind of like a highly low labor, highly automated task that really is very, very successful for us. So that's a really good jumping off point for looking at this, and that's exactly the kind of like highly automated kind of stuff we need to be doing for this market. Now, Collins also mentions that it's the 8th NADCAP accredited additive manufacturing site. So I was like thinking, like, what are the other sites? So I started to try and look them up for you and trying to figure out who they were. The first of the obvious ones are Morph and Centavia, right? Then Siemens Material Solutions also has a NADCAP site. Then we've got Burloak, right? Then we've got Toolcraft, which is a German producer of additive manufacturing components. Georg Fischer, GF, right? Additive. Now, one of them I think is a site, but I'm not 100% sure that's not this NADCAP accredited. Is Maxar. With Maxar uses additive manufacturing and production satellites, satellite components, and that kind of thing. And maybe Safran, I was thinking, but I've been able to find that. Safran I wouldn't be able to find. Maxar is like a maybe. And then there's another one, there's LAI International, which is a company that is also a supplier of a lot of E-beam and other type of parts to military and aviation that also has this NADCAP certification. This makes the Collins site the 8th one to have a certification. Now, this is really, really important because it's a really very, very important certification if you want to sell military and other similar type of things to the US government. So tracking the number of people making the considerable and super mega annoying investment and time and money in doing this, is a really good way of assessing how much effort and how many parts are actually rolling out of 3D printing for defense. So this is it's a good development for the market. Again, we must not become too much of a defense kind of thing. These guys are so big, and the projects are so big, and then the money paid or given by governors to companies and all is so large that our company, our industry could really, really get swallowed whole by something like this. So that's why I keep focusing, coming back to this kind of stuff. Now, the next thing is some news by Igus. Now, Igus is a company that's a really cool company, I think. They make motion control stuff. They make bearings. They make these e-chains or energy chains that are kind of like chains to guide wires, wiring harnesses, and especially the kind of moving kind of components. If you've got a motion stage, like an e-chain or energy chain is also called, is a good way to guard all the cabling in that motion stage so it doesn't get caught up in other stuff. And these are used on tons and tons of different, industrial machinery, robotics equipment, production lines, that kind of thing. Now, Igus is already very revolutionary in space. What Igus essentially does is it kind of uses plastics with really, really low wear resistance and really smooth type plastics to make lightweight, often less expensive, very often very high quality kind of good products that people use in these automation systems. Igus is also a dream to work with, by the way, in small volume stuff. You can really easily pick up samples from them. You can really easily order small parts in their catalog, and they're really quite transparent in pricing stuff. So I love them very much. Indeed, if you're trying to build a 3D printer, often just going to Igus and buying all the parts is often much simpler and faster than just trying to have to shop around and try to figure out what other people's prices are. So it's really nice. I think they're really super transparent, and I really like them as a company. Anyway, so what did they do? Now, they've been experimenting with 3D printing for a long time. They offered a 3D printing motion stage at one point. They offered an Igus, like the same kind of smooth type wear smooth wearing kind of material. They offer it as an FDM filament as well. And now they have the P-Rack. Now, the P-Rack is a custom components, 3D printed, e-chain kind of system. Now, it's made within 36 hours of the order. And this could include things like custom holders, custom components, even unique geometry, unique sizes of this thing. And they 3D print it all in-house. They say they've got a lead time reduction of 66%. The thing is 80% lighter than a lot of conventional alternatives, and this could save lots of money. And I love the fact that Igus is going into this kind of like on-time manufacturing of custom components. You could see that if they already make the motion stages and stuff, so they make most of the printer anyway. So for them to make a print farm would be super cheap, right? And for them to branch out in these kind of areas, I think would be really exciting as well. So I think it's cool that such a transparent company as Igus and a company that generally delivers very, very good components is getting into this space. And I think there's a huge opportunity here to do a lot of more parts made on delivery, made on demand for, a machining solutions, machines, machine builders, and production lines. And I think it's a fantastic market for Igus to jump into. So really, really smart on their part. The next thing is, something went wrong with the picture. Sorry about that. But that's by Balena. Balena is a compostable polymer company. So they're essentially making materials that have a defined end of life, that are compostable end of life, and they're programmable compostable, let's say, so they can design a material that is compostable and that works and that is great under certain circumstances. Now, the material is called BioCir, and CIR, CIR. And essentially, it's an elastomer that's compostable. Now, what they've now done is they've worked with Kitty Shukman, and they've worked on a slide, and that is a shoe type, let's say, and that is made out of that compostable elastomeric material. The shoe itself has roots and branches, and it evokes a kind of a tree. What I really like about this is actually really cool, is that she made one left side of the shoe and the left and right side of the shoe, and they're both different. I think that's really cool that all these people are 3D printing shoes, but they're still making both of the shoes look different. And there's no reason at all to do this, of course. So I think that's really kind of cool, little simple thing, but a nice thing anyway. And I also like the fact that other people were just saying, "Oh, it's so sustainable. Our shoe made out of TPU is so sustainable because it's one material, and using shoes is like 100 materials, so it's easier to recycle." Well, yeah, but this thing that Balena is doing is, of course, a lot more sustainable. This is a lot more better to have a thing that you can just literally plant in your garden at the end of the day. So I think it's fantastic. It's great to see real, true material innovation, and wonderful move by Balena and Kitty Shukman. And that's it for today, guys. Thank you so much. This was 3D Printing News Unpeeled. My name is Joris Peels, and I hope this was useful.